Good morning, students. On behalf of Dr. Subhash Technical Campus, we warmly welcomes you on online tutorials for the subject of network administration and SEO. In last lecture, we discussed OSI model. In this model, we discuss the history of OSI, International Standard Organization, and what is the role of it, why it requires all those things. We also discuss basic layers from the 7 defined layers. The 7 layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and last one, that is application layer. In last lecture we discussed physical layer, that is completely deal with physical media on which we are passing our information. It deals with bits. After that, data link layer, it has 2 separate parts: logical link control layer and media access control layer. It deals with frame and it receives data from network layer as well as physical layer. We also discuss the format of frame. It has 3 basic components with a frame. These are header, package, and trailer. Today we move forward and discuss about network layer and next transport layer and all available layers. So basically, what network layer works, how network layer works. So that is in our hierarchy, it is 3rd layer, network layer from the bottom to top, where we discussed that is a 3rd layer: physical layer, data link layer, and now network layer. It determines the best path to move data. That is first functionality, basic functionality of network layer. What it determines? It determines the best path to move the data. How select the best path? Using algorithms: shortest path, nearest neighbor. There are so many algorithms available to find shortest path. Shortest path. There are so many methods and algorithms available in computer science that we discuss in later. But how can move the data with the best path? How we consider a best? So we have to plan a shortest path. First one, that is shortest path. Another one, that is less consecutive. That means that path may be free as and when required. There should not be more traffic on this particular path. So deciding how best path is work for us and work for moving transmitting data from one workstation to another workstation, we have to measure all these things. So it determines the best path to move data from source to destination based on network conditions, priority of services, and other factors. Another one, data link layer is responsible for routing and forwarding the packets. Routing and forwarding the packets. Routers are layer 3 devices. They are specified in this layer and used to provide routing service within the internet network. Routing to find the route from source to destination. That is the basic work of routing. So routing mechanism is implemented in this layer. Another one, network protocols are used in this layer. To move your data from source to destination, we have to use some protocols, and these protocols are IP and IPv6, IPv4, that is defaultly used as IP, and IPv4. Internet protocol version 6, Internet protocol version 4, IPv4 as well as IPv6. So how IP addresses are allocated to our system, that is a separate portion that we discussed in later on. But IP address, that must be a name of a computer. Using this particular IP address, your computer, your workstation can identify within a network. As we have a name, suppose my name is Bhargav, another person his name is Rahul, another person his name is Rajiv, and these are the name. Name can be used to identify a particular person. Same like IP address is used to identify a particular device. Those devices are connected in a network. Those devices are connected in a network. Each connected devices have a individual unique IP address. That is a pattern of IP address. Okay, so there are some protocols are used. These are IPv4 as well as IPv6. And inter-networking is the main responsibility of network layer. It provides a logical connection between different devices. Devices may be your computer, maybe your mobile phone, maybe your printer, maybe your scanner. All the peripherals, those are connected in a single group, in a network, to maintain the connectivity, logical connectivity between all these devices, and all these devices work simultaneously in a single group. That is the core functionality of network layer. It also called in a single word, that is internetworking. That is internetworking. Now next, a network layer adds a source and destination address to the header of the frame. In previous layer, that is data link layer, we discussed about frame. So what frame, how frame determined? It has a header, context, portion and trailer. Now in the network layer, as frame goes ahead, network layer adds the source as well as destination address to the header of frame. Addressing is used to identify the device on the internet. Okay, why we are using addressing? To identify a particular computer within a network. That is another word, another task, and that is addressing. Internetworking, addressing, and next one is routing. Routing is a major component of a network layer, and it determines the best optimal path out of multiple paths from the source to destination. That is routing. Say if we want to traverse from one place to another place, so before traveling, we find out a shortest path. First one, we find out the shortest path. Second one, we also measure a traffic. A route is with a very heavy traffic or average traffic or low traffic. We prefer average or below average traffic route. First one, that is shortest. Another one, traffic, and that is quality of a path. And third one, a road is safe for traveling. That is our consideration. So in network, computer can also identify which route is optimal to traverse data from source to destination. Right? Okay. And last one, that is packetizing. A network layer receives the packet from upper layer, that is transport layer, and converts them into packets. If transport layer provides the data in another format, then network layer will convert all the data in single packet. And that is, it is achieved by Internet Protocol IP. That is packetizing. So network layer mostly deals with to maintain the logical connectivity. It uses the protocol IP protocols. It deals with internet working, addressing, routing, as well as packetizing. Here we have a diagram. In this diagram, above layer, that is transport layer. So transport layer provides data to network layer. Network layer convert this data into packet and pass these packets to the data link layer. Now data link layer we convert into frames and pass to the physical layer. Physical layer will convert all the frames into bits and transmit the bits from physical device. Now reverse, from the data link layer, access the frame, get the frame, convert into packet and pass it to the transport layer. This is the system, this is the paradigm of working, paradigm of network layer, right? Okay, next one, and that is transport layer. That is transport layer. This layer performs a very critical and very important part of OSI layers, 7 layers. Transport layer, that is the 4th layer. That messages are transmitted completely in order in which they are sent, and there is no duplication of data. What is core functionality? It checks a complete data must be passed from source to destination without any duplication. Duplicate data may not be considered as the original text, as the original data. So at the transport layer, it removes the duplication. Okay, it receives the data from upper layer and converts them into smaller units known as segments. These words are more important. See, physical layer, data link layer, network layer, and now that is transport layer. Physical layer deals with bits, data link layer deals with frame, network layer deals with packet, and now transport layer deals with segment, bit, frame, packet and segment. Individual word relate with individual layers. Okay, got it. I hope you clearly understand what I want to convey a message to you. So it receives data, transport layer receives the data from the upper layer. Upper layer is what? That is session layer, and converts into smaller units, that is known as segments. Here also there are two protocols are used. These are transmission control protocol, TCP, transmission control protocol, TCP. Another one, that is user datagram protocol, UDP. Now we have two different words. These are TCP and UDP. Now one terminology come into existence, that is connectionless and connection oriented and connectionless communication. What these are? Suppose we want to make a communication between one person to another person using a mobile phone. Then it is compulsorily receive mobile phone your call at the endpoint. otherwise we cannot communicate. See, I want to make a conversation between person X using mobile phone. I am dialing a number of Mr. X. It must be Mr. X have to receive my mobile phone, my call. Then and then we can communicate between me and Mr. X. Until while he is not receiving my call, I cannot communicate with him. That is connection oriented transmission. After establishment of a connection, we can transmit our data. That is a way of textual verbal communication. That is a way of verbal communication. I am saying something and he is listening. He is saying and I am listening. That is a verbal communication. But after making a proper communication, proper establishment of a connectivity, we can transmit our data. That is connection oriented communication. So as and when we want to pass our data compulsorily on connection oriented, then we have to use TCP, transmission control protocol. Same like WhatsApp message or text message or emailing. There is no need to actively participation of endpoint person. Mr. X may not be live at the same time, even though we can pass our mail. As and when he will be live, there is a notification, you have a mail from Mr. Bhargav. Then there is no need to make a communication, there is no need to make a connection at the time of transmission your data. That is then we are using user datagram protocol. Okay, now listen, now read it. TCP, it is a standard protocol that allows the systems to communicate over internet. It establishes and maintains a connection between hosts, that is workstation 1 and workstation 2. When data is sent to a TCP connection, then the TCP protocol divides the data into smaller units, and that is segment. Now transport layer compulsorily deal with segments. Each segment travels over the internet using multiple routes and they arrive in different order at the destination. Now there is a problem and there is a mechanism. See, if we have multiple paths and we want to transmit our data from source to destination within a limited time, so we can use all the path at same time. Suppose we have 4 packets and we have 4 different paths, so we can pass these 4 packets, 4 segments with individual path. Packet number 1 using path A, packet number 2 using path B, packet number 3 using path C. So total time may be divided by 3 and this time may be used to transmit another packet, but it occupies a less time to transmission. But there is the problem, we have to rearrange in a proper sequence, otherwise packet C will arrive first, packet B will arrive third and packet A will arrive second. So A, B, C is not a proper sequence at the source destination point. It may be B, A, C. So we have to rearrange into A, B, C. So that is the arrangement. This transmission control protocol reorder the packets in correct order. That is the task of transport layer and our protocol TCP, transmission control protocol. Same like user datagram protocol. The user datagram protocol is transport layer protocol. It is an unreliable transport protocol, as in this case receivers does not send any acknowledgement. In TCP, we can get back SCK bit, acknowledgement bit. TCP will provide after completion of transmission from source to destination. It will provide the acknowledgement bit. That means we have successfully received the data, and we may arrange this data in particular sequence A, B, C, and that is your acknowledgement. We have successfully received your data. TCP will provide this acknowledgement, but UDP may not provide this acknowledgement. So when the packet is received, the sender does not wait for any acknowledgement. Therefore, this makes a protocol unreliable. That is unreliable protocol, UDP. We have to discuss, we have to remember a limited text, limited portion here. What transport layer will perform, how transport layer will work. So first thing, it make our data into segment. It has two protocols, TCP and UDP. TCP will rearrange your data in proper sequence. It maintains multiple routes to pass your data. UDP, there is no acknowledgement bit passed to the sender, and that's why that is unreliable protocol. So that is a workout of transport layer. There are detailed functions of transport layer also available. That is service point address. That means there are so many programs work simultaneously at the same time. There are so many processes are working in background also. So one process to another process may be added into transport layer. What it works, the transport layer adds the header that contains the address known as service point address or port address. It adds service point address and transmit the message to the correct process. If we have multiple processes, say for example process A, process B. Process A works to get input from the user. Process B works to make a process on this data. Suppose if we are using a simple example, whatever user will input in our system, we have to capitalize the text. So process A is get or receives inputs from user. Process B is capitalize the entered value. Whatever value is entered by user, we have to capitalize. So service point addressing, that means there is one process to get input from user. So transport layer will add header node, header information, where is the process, what is the actual address of this process to get input from user, and where is the address of process to make capitalize. So service point addressing. Segmentation as well as reassembling, we have to arrange in a proper sequence. After making a proper sequence, we have to reassemble. That is segmentation as well as reassembling. Connection control. During the communication, during the transmission of data, the connectivity must be live. So connection established, connection oriented service as well as connectionless service. Connectionless service treat as a segment as an individual packet. Connection oriented service make connections with the transport layer at the destination before delivering the packets. Say, I discussed earlier, as and when we are using connection oriented service, then we have to make a physical connectivity between two hosts for whole time. What time? We are using transmission of our data. That is connection oriented service. And connectionless service, there is no need to make a connectivity between live connectivity. Connection oriented service, all packets travel in a single route. We cannot use multiple route with a connection oriented service. If we are not using connection oriented and we are using connection less service, then we have to use UDP, user datagram protocol. Another task, that is flow control. What is the flow? To transmit our data in a sequence, in a segment of our data, whatever flow we are using to transmit our data. And last one, that is error control. Transport layer also deals with error control. Error control is performed at end to end. It executes at end point, that is source as well as destination. On the destination part, it checks, is it any error in a sequence, error in a sequence, error in a transmission medium. Somehow our data may be lost during the transmission. So is there any error? That is controlled by transport layer. So transport layer is most important and work from OSI layer. So basically it converts our data into segment. It uses two protocols, TCP as well as UDP. There are some functionalities related to transport layer like service point addressing, segmentation and reassembling, connection control, flow control and error control. Now next layer, and that is session layer. I hope all of you know what is session. In internet connectivity, whenever we are logging in particular application, then there is one session is created, a particular time duration in which user is alive for transmitting your data. That is a session. That is the basic meaning of session. So session layer, what it functionality, how it works, used to establish, maintain and synchronizes the interaction between communicating devices. Here it must not be there. A two-person may communicate in computer network. Data transmission may be performed within two workstations or to any peripherals, to devices. So what is the task of session layer? It used to establish, maintain and synchronize. First one, establish the session, maintain the session and synchronizes the interaction between communication devices. Session layer acts as a dialog controller. Whatever host A passes the data to B and B passes the data to A, that is in a synchronized manner, in a sequential manner. So in session layer it establishes the session. Session layer adds some checkpoints when transmitting the data in a sequence. With checkpoints, so first it checks the error control, session is live or not, authentication. These all the checkpoints covered by session layer. If some error occurs in the middle of transmission of data, the transmission will take place again from the checkpoint. Right? Whenever in Oracle you also learn rollback and submitting your data, that is a checkpoint. So we want to check a fraction of data, a portion of a data in a system, then there should be a checkpoint. So after recovering of data, this data whatever stored in a system up to the checkpoint, that is permanently saved. That is the checkpoint. The process is known as synchronization and recovery. That is synchronization. Next one, and that is presentation layer. How to present your data? We quickly revise the model. Here we have 7 layers: physical layer, data link layer, network layer, transport layer and session layer. We discuss all these 5 layers. First one, physical layer, actual implementation of data, actual implementation of your connectivity. It uses bit. Data link layer, it passes your data within a frame. Network layer, packet. Transport layer, segment. Now we discuss about session layer. Up to the 4 layers we deal with transmission, exactly transmission of our data. There is no user connection, user interaction in these 4 layers: physical layer, data link layer, network layer and transport layer. Now in session layer, a particular session, a particular time duration is must for a half an hour, for a 45 minutes, for a 10 minute, up to while the data is not completely transmitting. That is also a part of session timing. So that is used in session layer. And now we will discuss about presentation layer. Physical layer, data link layer, network layer, transport layer, session layer and presentation layer. Presentation layer mainly deals with syntax and semantic. Now what is syntax? That we know. The actual formation of a transmission of data in this particular sequence, in this particular format, we may transmit our data. That is the syntax. And what is semantic? Rules, grammatical rules, that is used in system software. What are the grammar may be implemented using this transmission of data, right? So syntax and semantic of information exchange between two systems. It acts as a data translator. What is the role of presentation layer? The role of presentation layer is works as a data translator. Now see figure first, diagram. In this diagram, from the application layer we are receiving some data, and that may be in a simple format. So encoded, encrypted and compressed data are received in presentation layer. Encoded, encrypted and compressed data. What is encoding? Encode, decode. That means we have to change the particular language, particular formation of our data. That is encoding, coding, decoding, encoding. Encrypted, there are so many encryption methods that also we discuss in later on, but encryption, that means we have to change the format of our data so that unauthorized user may not be access, or if they are accessing our data, they cannot be interpret what we want to convey. So that is the encryption. And compress means we have to compress our data in a small less amount of storage. If we have 500 bytes of data, and after compression algorithms, after implementing these algorithms, this 500 KB of data may be in 450 KB of data. So compression techniques are also available, but within the presentation layer, they receives data may be in encoded, encrypted and compressed manner. After removing this pattern, it passes the data to level 6, and that is session layer. As in the reverse manner, whatever the information collecting from the session layer, it will decode and decrypt and decompress the data and pass it to application layer. So user, at the last layer we also discussed in coming slides, in the application layer the user interacts and user can see what actually the data transmit from the source to destination. So that is in application layer, but in the presentation layer it will perform encoded, decoded, encrypted, decrypted, compressed and decompressed of data. Here this layer is a part of operating system that converts the data from one presentation format to another format. It implements encoding methods to encode your data. It also converts your data into readable form or understandable form. That is a data translation. Another one, that is encryption. So it maintains the privacy. Encrypted data, unauthorized users may not access the data. That is encryption. Encryption is a process of converting the sender transmitted information into another form and sends the resulting message over the network. See, there are 5 persons directly communicate in a network, and person A wants to communicate with person B, but it intends that remaining persons may not know what I want to convey with B. So there is a gestures, face expressions is a method to pass the message, and maybe remaining persons may not know what I want to convey the message. That is a privacy, right? Encryption. Compressing of a data, it reduces the number of bits to be transmitted. So as and when we reduce the bit to be transmitted in a layers, so that is less transmission over network. So works of presentation layer deals with syntax as well as semantics. It converts the data from one format to another format related to encryption, encoding and compression. Okay, and last one, and that is application layer. It directly deals with human. See here, user comes into picture. User at the sender and the receiver. An application layer serves as a window for the user, a window from which user can transmit the data as well as receive the data. So it may be treated as a window. It handles issues such as network transparency, resource allocation, resource division, load balancing. All this work are done at the application layer. Application is not an application, but is perform the application layer functions. It performs the functions. See here, there is one protocol used in this layer, and that is File Transfer Access and Management, FTAM. These are the functionality work at the application layer, and we can say the example of application layer, that is a mail servers, directory service, user directory, user applications. All these are work in application layer. In short, whatever we are accessing the data, that directly comes at application layer, right? So again we have a basic chart related to all 7 layers. See here, physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. If we want to remember in a single sentence, so physical layer to transmit bits over a medium to provide mechanical and electronic specifications. Data link layer, it organizes bits into frame. It provides hop to hop delivery. Hop to hop means station to station, node to node delivery. Network layer to move packets from source to destination to provide internetworking routing algorithms. Transport layer, it provides the reliable process to process managed delivery and error recovery. There are so many processes works in a same domain, so we have to communicate between each process. Remote method invocation, remote processing, these all are at a transport layer. Session layer, it establishes, manage and terminate the session. Presentation layer, translate, encrypt and compress data. Application layer, it allow access to network resources. This is a complete OSI model. Now we will watch a video that is very useful to understand and how to transmit your data from source to destination.
The ISO, or international standard as we would like it to be. The world we live in is still neither as smart nor as connected as we would like it to be. Until in the mid-1980s, the ISO, or International Standard Organization, developed a networking model to provide standards that will become the basis for network designs. This is the OSI model. 7 layers build up the Open Systems Interconnection, or OSI model. Let's take the flow of data and represent it with a training system. Sending a file or clicking a link in your computer ignites the flow of information. The first layer to receive the command is the application layer. The application layer serves as the window for the users and application processes to access the network services. This layer contains a variety of commonly needed functions like resource sharing and device redirection. Data are packed and ready to take on a long journey. After the data is read, the next layer, or the presentation layer, formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station. It then translates the common format to a format known to the application layer at the receiving station. The presentation layer also encrypts control information into the data, in this case, the train, to be read by the next layers. This layer allows session establishment, maintenance, and termination, which allow 2 application processes on different machines to establish, use, and terminate a connection, called a session. This session support, which performs the functions that allow these processes to communicate over the network, performing security, name recognition, logging, and so on. This layer remembers everyone who passes by. After another journey, the data pass through a layer of security and validity, the transport layer. This layer scans and makes sure the data is reliable and valid, and that the message messages are delivered error-free and then broken down or acknowledged into segments. A security firewall is usually in action at this layer. Data that do not pass will be rejected or destroyed. And because the session layer before remembers the data that gets through, data are retransmitted when there is no connection acknowledgement. This is the safe haven of the data whenever data packets are lost. Down to another layer is the network layer. Here, the segments are encapsulated into packets. Routing takes place in this layer where the path the packets will take is determined. Packet filtering routers and firewalls sometimes take place in this layer. The lower the firewall in the layer is, the more secure the network. An additional responsibility of the network layer is that it adds a source and destination internet protocol or IP address to the segments. The next layer is the data link layer. The packets are turned into frames for the specific networks. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmissions over the link. A switch in networking takes place in this layer, where packets are read of its control information and then encoded with the media access control or MAC address. The MAC address contains 12 hexadecimal digits and prevents collision in the same region. Finally, the physical layer transforms the frames into bits and then sent over the network via physical hardware or medium, in this case, the Ethernet. Data are logically arranged and encoded before they get sent to a physical medium, to another computer, and is then received by another computer's physical layer. Some data or information in the upper layers are destined to be sent through the internet, a vast interconnection of information and data. Either way, the data sent will then be received by the 7 layers of another computer, from the physical layer, which encodes the bits, back to the data link layer, where the bits become frames and is transferred error-free, to the network layer, where frames turn back into packets and then sent to the upper layers, and to the transport layer, where validation and firewalls take place. Sent up to the session layer, where connections called sessions are maintained or terminated. Back to the presentation layer, where the data are turned back into a format that can be read by the presentation layer. And finally, sent and presented to the user via the application layer, where you will be provided with your request or command.
Okay, I hope you clearly understand what are the uses of OSI layers. These 7 layers are most useful in the computer network. Thank you so much.